Good morning friends. In the previous lecture of determinants, we are study about that the minor and cofactor. We are study about the minor and cofactor, and today we are talking about the adjoint of A and inverse of A, either adjoint of matrix and inverse of the matrix. First you know that what is the adjoint of the matrix. Okay, adjoint of the matrix, it is written in the short form ADJ of A. It means adjoint of A. Adjoint of A, suppose that you have a matrix and in the matrix you take the cofactor. Here is taken the cofactor. Suppose that you have a matrix A11, A12, A13, A21, A22, A23 and A31, A32 and A33. And if you just wanted to find the cofactor, so here the cofactor of that matrix is A11, A12 and A13, A21, A22, A23 and A31, A32 and A33. This is the cofactor of that matrix. Suppose this is the matrix is A, so this is the cofactor of A. This is the cofactor of A. So in the case of the, if you take the cofactor and you take the transpose of that cofactor, if I take the transpose of cofactor, it means if you convert row into the column, so this is equal to adjoint of A. If you take, you listen in a proper way. Here is a cofactor. According to the minor, we can find the cofactor, and if you find the cofactor, after then you take the transpose of the cofactor. Transpose, it is written in the form of a to the power t, either a to the power dash. This is called as the transpose. If you are take the transpose, so it is equal to adjoint of A. So here adjoint of ADJ of A, adjoint of A, that is equal to, you convert this row into the column. So this is equal to element A11, A12, A13. Similarly, second row you convert into the column. So this is equal to A21, A22, A23. Then third row it is also converted into the column. This is the A31, A32 and A33. So I think all of you understand how we can find the transpose, and the transpose of the any matrix, that is equal to adjoint of any matrix. Okay, so I think all of you understand adjoint of any matrix in the form of 3 by 3. Second condition, if you have a 2 by 2 matrix, 2 by 2 matrix, in that situation how we can find the adjoint of A? Suppose that you have a matrix, that is example that the elements of A11, A12, A21 and A2, and you just wanted to find the adjoint of A, ADJ of A. If you find the adjoint of A, in that situation, that the adjoint of A, you take this element A22, then another elements of the column, this is a with negative sign of that element, this is a minus A21, this is that elements. After that you take that element minus A12, you take the negative sign, and this is the A11. Reason, if the power of minus 1 to the power, here is I plus j. In the case of the power I plus j, if the sum of ij is an odd number, so it is converted into the negative sign, and if the sum of the I plus j, it is equal to even number, so it is converted into the positive form. So you write down as like this, that adjoint of A by 2 by 2 matrix. Okay, so I think all of you understand how we can find that the adjoint of any matrix. Second condition, inverse of the matrix. How we can find the inverse matrix? In the case of the inverse matrix, how we can find the inverse? The first condition is that first you find that the mod A. It means the value of any matrix. If you have find that the mod A, if the mod A exists, it means it does not equal to 0. If mod A that does not equal to 0, then you can find the inverse matrix. Suppose that if mod A that is equal to 0, then you can't find that the inverse matrix. Okay, so the inverse matrix, it is denoted by the A inverse. Suppose that I have an inverse matrix, I written that A inverse that is equal to 1 upon mod A and into adjoint of A. This is the A inverse, and all of you know how we can find the adjoint of A. Okay, so if you find just inverse matrix, then you apply that formula, A inverse that is equal to 1 upon mod A and adjoint of A. Okay, so we are talking today about the adjoint of the matrix and the inverse of the matrix. I explained that how we can find the adjoint of any matrix and how we can find the inverse of any matrix. Okay, so all of you see and write down this. Okay, fine. Next, we are going to solve some questions related, some problems related to that. Here some problems are given, so I talk about the some problems of the given exercise. Here the exercise number 4.5 is given. Exercise number 4.5. Exercise number 4.5. The question number first. The question number first, find the adjoint of the each of the matrix in exercise question number 1 and 2. Question number first is, the matrix is that element is a 1, 2, another element is a 3 and 4. Okay, so how we can find that the adjoint of that matrix? Okay, so first condition, you take A11. Okay, if you take the A11, then you remove the first row and first column. So element -1 to the power 1 plus 1, because I is 1 and j is also 1, and the element is that element is a 4. So this is equal to A11 minus 1 to the power 2. It is a positive, so that is equal to 4. Second condition, you take another element A12. This is equal to minus 1 to the power 1 plus 2. That you remove the first row and second column, so the element is a 3. So here is a 3, and that A12 that is equal to minus 3, because this is the odd number. Third condition, you take A21. In the case of A21, minus 1 to the power 2 plus 1 and the bracket. You remove the second row you remove totally and first column, so the element is 2. So this is equal to 2. Therefore A21 that is equal to minus 2. After that A22 it means minus 1 to the power 2 plus 2. Okay, then here you remove the second row and second column. If you remove second row and second column, the element is 1. So A22 that is equal to here 1. After that you write the cofactor. Suppose that this is a cofactor, so this is equal to in the form of A11, A12, A21 and A22. Okay, you put up the element. A11 that is equal to 4, A12 that is equal to minus 3, A21 that is equal to minus 2 and A22 that is equal to 1. After that you take the transpose. If we are taking the transpose, so this is equal to A transpose, that is equal to adjoint of A, adjoint of A, that is equal to, here you convert row into the column, so the element 4 and -3 and this element -2 and 1. This is the adjoint of A of the 2 by 2 matrix. This is the adjoint of A 2 by 2 matrix. So I think all of you understand. Similarly, you have 3 by 3 matrix, then you also find that the adjoint of A. Okay. So in the next questions we are find out about the inverse here, that how we can find the inverse of the matrix. So the question number 5 we have solved. The question number 5, how you can find the inverse matrix. So question number 5 is that here I take the 3 by 3 matrix. So the question number 7 that here element is 1 0 0 and 2, then 2 0 and then 3 4 and 5. Find the inverse of each of the matrix if it is a exist in the question 5 to 10. Okay, so I take the question number 5. First I find the value of mod A. Mod A, that is equal to mod A. First I take 1, this is a multiply, 2 5s are 10 minus 0 4s are 0 minus 2. Then I take 0 5s are 0 and 0 4s are 0. Then first I take 3. Then this is equal to 0 into 0, that is 0, 2 into 0, that is a 0. So that is mod A 1 into 10, that is equal to 10. Mod A does not equal to 0. Mod A does not equal to the, since mod A does not equal to 0, so the matrix is exist. Matrix is exist. If the matrix is exist, then at that situations you find the A inverse. After that we find that the cofactor. So first I take A11. You see A11, the power is 1 1 plus, it means plus, so you take 2 5s are 10 and 0 0s are 0, it means this is equal to 10. Then A12, it is a negative sign, then this is equal to, you take 0 5s are 0 and 0 4s are 0, so it is equal to 0. Then A13, that is equal to, you remove this column and this row, so this is a 0 0s are 0 and 0 2s are 0, so it is also equal to 0. Then after that A21, the sign is negative because 2 plus 1, that is equal to 3. You remove second row and first column, so this is a 2 5s are 10 and 2 0 3s are 3, so 2 5s are 10, this is equal to 10. Next A21, that is equal to A21, this is equal to, you remove second row and second column, so this is a 1 5s are 5 and 0 3s are 3, so 2 plus 1, that is equal to 2 2, this is the A22, so it is a positive, and 1 5s are 5 and minus 0, that is equal to 5. Next A, this is the 2 3, this is equal to, you remove second row and third column, that is equal to 1 0s are 0 and 2 0s are 0, it is also equal to 0. After that we are going for the third row A31, the sign is that negative, so here positive, 3 plus 1, it is a 4 positive, you remove the third row and first column, so 2 4s are 8 2 4s are 8 minus 2 3s are 6. So that is equal to 2. After that, then this is equal to A32. A32, that is equal to, you remove the third row and second column. If you remove third row and second column, it means 1 4s are 4 and 0 3s are 0. So that is equal to negative 1 4s are 4. So it is a 4. And 0 3s are 0. It is equal to 0. Next, A33. That is equal to positive. You remove the third row and the third column. So this is equal to 1 2s are 2 minus 0 2s are 0. So this is a 1 2s are 2. It means 2. Okay. So after that, you take in the form of the cofactor. So this is equal to, elements are 10 0 0 and this is a minus 10. This is a 5 0. The element is 2 minus 4 and 2. This is the cofactor. After that, you take the adjoint of A, either transpose. So this is equal to adjoint of A. This is equal to, you convert row into the column. So this is a 10 0 0 minus 10 5 0 2 minus 4 and 2. This is the value of adjoint of A. After that, how you can find A inverse? So A inverse, that is equal to 1 upon mod A and adjoint of A. So the value of mod A, that is equal to 10. So 1 by 10 and adjoint of A, this is equal to 10 0 0 minus 10 5 and 0 2 minus 4 and 2. Okay. So you can write down in the form of 1 by 10 and this is the matrix 10 minus 10 2. Then another is a 0 5 minus 4, then 0 0 and 2. This is the value of A inverse. So you can find the A inverse. So I think all of you understand how you can find the A inverse and adjoint of A. Okay, I think all of you understand. Okay, goodbye.